Hello, 8th graders. Your video is going to be covering section 7.4 from the book, which is on similar figures. And so similar figures we've talked about several times. That just means that they have the same shape, but they're not necessarily the same size. Because if they were the same shape and same size, they'd be called congruent. So in the book, they use this to mean similar. Okay, remember the other day we talked about this means congruent when you have a wavy line on top of a equal sign. This one is just the wavy line, that means similar. So then similar polygons, and remember that's just a closed figure shape that has lines that doesn't cross and no curved lines. It's just basically any shape, right, that meets those criteria. So corresponding angles have to be congruent. Okay, corresponding angles have to be congruent. The lengths of the corresponding sides have to be proportional. Okay, so the ratios, right? So if this one is a third as big as this one, every side has to be a third as big. Okay, the ratios. All sides have to be in proportion. So if I drew a couple of triangles here, so let's do a bigger one, and we'll do a smaller one. And let's put some side lengths in here. So let's say that that is 6, 10, 8, 3, 4, 6. And this does not just work for triangles, it works for any polygon as long as all angles are congruent. And so we know that we have right angles right here, right? And so let's just say this is, I don't know, 40, which would make this one 50, because they have to add up to 180, right? So if the angles are all the same, that's great, but that isn't enough to give you the answer to whether these two things are similar or not. You have to check the ratios of the sides. I normally start with the smaller figure first when I'm doing this, just because then I won't have top-heavy numbers. Okay, so find the sides that match up. This side corresponds to this side. So 3 is to 6. Then I'll do, again, I have to start with the same triangle each time, so I'm going to do 4 is to 8. And then I have 6 is to 10. Match up your sides, and then you're going to reduce, and see all three of them have to be equal. So this one is no. They are not similar, even though they really look like they are. They're not. Okay, because all of these ratios have to be the same. If you have one that's different, it's automatically not. It doesn't matter that all these angles are the same. The sides also have to be proportional. So then, because when you know that two things are similar, you know that the ratios have to be in proportion. So then, if I have two figures, so let's use trapezoids this time. So I'm going to say that the bigger one is 10. Whoops. The bigger one is 10, and we're going to use feet. And 16, and the height is 4, which I don't really need the height to do this, right? It's going to be extra information. So x is 12. Okay, so I have an x here, which I need to solve for, okay? And I have to have at least one other set of sides that I can use for the proportion, and then I need the side that corresponds to the one that's missing. So I'm going to again start with the smaller one. So I'm going to go x is to 10 because they are corresponding. And then I'm going to go back to the small figure, and I'm going to go 12 is to 16 because they're corresponding. And then I am going to solve my proportion. So crisscross, right? 16 times x is 16x. 10 times 12 is 120. And then if I do my last step here, I get rid of the 16 by dividing. So 120 divided by 16 must go about Okay, so that goes 7 times. And that's 112, and that leaves 8. Bring down another 0. Better put my decimal in. And 16 goes in there evenly 5 times. So it comes out right there. So my x equals 7.5 feet. Because they have to be proportional, right? The side lengths have to be in proportion. You can set up a proportion to solve for what's missing. That's how you can use one figure to find what's missing on the other one. So bring that knowledge with you, and we'll talk about it more the next time I see you.